In the last video, we took a look at the slope-intercept form of the equation, focusing on slope. And now I feel comfortable going ahead and giving you the equation for the slope, which is that m is equal to y2 minus y1 over, that's the difference of y's, x2 minus x1. And that's the difference of x's. And all we really use these little subscripts to, these little sub numbers, is to tell you that we have a different point, two different points that we're talking about. One is x2, y2, the other is x1, y1. And it doesn't really matter what order you use them in, as long as you use them in the same order. So x2 minus x1, y2 minus y1. Or you could do y1 minus y2 over x1 minus x2. As long as y's are on the top, y's are in the numerator, x's are in the denominator, and you use them in the same order. Now in this video, I would like to focus a little bit more on our b, which is going to be b is our y-intercept. It's where the line crosses. So here is the first line that we looked at in the previous video, and we noted here that the slope of this line was negative 2/3. We go down every 2. For every 2 we go down, we're going to go over 3. Now what I want to take a look at is this point right here, where this line crosses the x-axis, because that will be our b. And as you can see, it crosses the x-axis at the point 0, 4. Now, at our y-intercept, x will always be 0, because the y-axis is where I haven't gone at all to the right and I haven't gone at all to the left. I'm directly on that y line. So if I know that my b, my y-intercept, that's my y-intercept, is 0, 4, then my b is 4. I can now write the equation of this line, because remember, I have the slope. Here's the slope right here. And the b is this number here, so that I can say that the equation of this line here, this particular line, is that f of x is equal to negative 2/3 of x plus 4. And it's a plus 4 because we cross out that positive 4 up there. Another way I could write it would be y is equal to negative 2/3 of x plus 4. And then every point on that line would make this a true statement. Whether I used 0, 4, whether I used 3, 2, or 6, 0, each of those would make a true statement. Well, let's try it. Let's take a look at the f of, let's use this point down here, 6. What is the f of 6? Well, negative 2/3 of 6 plus 4 is negative 2. See, those cancel to 2. So negative 2 times 2 plus 4, and that'll be negative 4 plus 4. So the f of 6, when x is 6, when x is 6, y is 0. And that bears fruit, right? That's our point right there that we graphed in the last video. Here, the y-intercept is at a different point, 1. There, the y-intercept is at 1. So knowing that we have a slope of 2, that's our m, and our b of 1, then I can say that the equation of this line here would be that the f of x is equal to 2x plus 1, or I could also say that y is equal to 2x plus 1. Either of these are interchangeable statements. And let's pick a point and prove that that's true. Let's say that we use this point here at negative 1, negative 1, negative 1, negative 1. That's kind of hard to see, I know. Negative 1 is equal to 2 times negative 1 plus 1. Well, 2 times negative 1 is negative 2 plus 1. Does that equal negative 1? Yeah, it does, in fact. So that's the b part of the y equals mx plus b. It's where it crosses the y-intercept. And that's a powerful thing to know, because once I know that my slope is 2, and then I have the information that my B, it crosses the y-axis here at 1, then all I have to do is start here at 0, 1 and go up 2 and over 1, and then I can draw my next point. Then I draw the line through those 2 points and I am done.